Hello and welcome back everyone to the next episode on SAP Analytics Cloud Training with me Anubhav. In our last session we talked about the concept of basics of machine learning. We saw the basics of what is machine learning all about. We also discussed about the concept of working with our machine learning scenario in terms of different scenarios what SAP offers for machine learning, and we saw the concept of classification. What is classification and how do we use SAP Analytics Cloud classification scenario in general? So whenever the output data is of type binomial nature, 0 or 1, we will use the classification scenario. Then we talked about the concept of how do we determine the accuracy of classification using the concept of confusion matrix. We saw the different ways to calculate different parameters like sensitivity, specificity, precision, and fallout. Also, we saw the example of using confusion matrix. Then we also see the different data points and we took an example of different patients being categorized based on their weight, and we also determine the confusion matrix for each one of them. And when we get a TPR and FVR, we plot a chart which gives us a perfect model. But we see in reality when we use Analytics Cloud, the perfect model is a dream scenario, but the real model will look like something like a line like this, which is close to the perfect model. And the model which is very close to the perfect model is considered to be the best. And that is how we will determine the accuracy for our classification scenario. So in today's session, we are going to continue and look at our real-time practical example, our business use case. So that was just a theoretical part to understand the classification. And now we are going to go ahead and look at how to actually use the classification scenario. So let us go ahead and see this in action now. So I'm just going to go and explain you our classification scenario, and then we are going to implement that also into the system. So once again, we have a spec document, just the way we have all the other scenarios and we have the spec documents. Let us go ahead and see this in action now. So meet Tony Hafner. Tony Hafner is basically a data scientist working with Anubhav Trainings. He has vast experience in working machine learning models. Yes. And also since 2011, he is working in machine learning. He led the development of machine learning program at Stanford University for, for machine learning and also taught online machine learning classes over hundreds of students, thus helping not just himself but also the community. He has been active contributor to all the machine learning and AI based platforms. Hafner also works on machine learning with an emphasis on deep learning. He has founded and led ATS Smart Insight project, which developed massive scale deep learning algorithms. This resulted in the growth of the company he has worked for, and his achievement, one of the achievement was algorithm developed on internet with a massive natural network with over 1 billion parameter learned from unlabeled Google ad traffic to help SEO experts to optimize their keyword targeting. So this is what was done by Tony Hafner. What are the job function of this data scientist Tony Hafner? Is to identify the data analytics platform that offer greatest opportunity to the organization, determine the correct data set and variable, collecting large data sets for structured and unstructured data from the disparate sources, cleaning and validating the data to ensure accuracy, completeness, and uniformity, devising and applying models and algorithm to mine the stored of big data, analyzing the data to identify the patterns and trends, interpreting the data discovery, and also providing the solutions and opportunities, connecting the findings to the stakeholder with visualization and other means. So these are the different job functions or the benefits or basically the main requirements which a data scientist will cater to in a company. So you can see these job functions. Why I put in these to this spec documents is because you can utilize these job functions to also put them into your resume. So you can prepare your resume accordingly. Yes. So what is the business story? Let's come to the use case. That's more important to understand. In today's digital age, the competition for high performing employees is a greater than ever, and cost associated to losing and replacing a talent is very expensive. So you see these days, after this pandemic, especially, employees are not ready to work. They are not ready to come to office. On top of it, if you say something to the employee little, he's ready to put down the paper. And there is a lot of buzz in the job market. A lot of companies are hiring talent, and a lot of people are quitting their job. Yes. So there is a lot of buzz in the job market. There are a lot of jobs out there, and a high performing employee, especially, is a rarity for a company today. It's very expensive to replace a high performant employee in a company. So organizations are looking to improve employee satisfaction to maintain loyalty and reduce the cost spent on recurring or recruiting and training for new employees. To achieve this, organization must take proactive approach to human resource instead of reactive approach. What does it mean? So many times you see that one of your teammate has decided to leave the company. He put down the paper, and after a week or something, he says, "Now I'm not leaving." Why? So there is some discussion happened between HR and your colleague. HR offered a little bit more of an offer, yes, to match basically the offer letter of the other organization, and that is how actually employee was retained. So that was a reactive approach where once employee put down the paper, that's when company is ready to match the offer, not proactively. Yes. So this will create basically the panic in the other employees, and other employees, it will go a wrong message that if we put down the paper, company is ready to increase the remuneration. So that's a wrong messaging, right? So company should take proactive measure to retain the talent rather than reactive. So Tony will review how the organization would typically review the HR related KPIs and understand how the SAP Analytics Cloud predictive features could influence proactive employee retention. So if HR has to contact all the employees, considering all of them will leave the company, it will be a huge cost overhead on the company, right? So today, if you think that everybody will leave the company, you will need to spend a lot of money to make the talent retain. Yeah, employee retention is expensive if you contact everybody to give the everybody some benefits, right? And it will also send a panic message to the company and spread rumors. So here the idea is to help HR department to detect potentially high risk employees which are expected to leave the company. Yes. So you can see the requirement here is to identify those employees which are potentially going to leave. So it's again one or zero. The person who will leave the company and person who will not leave the company. Last year, the company's attrition rate was 10.625%. That was the attrition rate, which means out of all the people, 10.625 people have left the company. So now Tony will use Analytics Cloud predictive scenario to help HR department meeting their goals. The goal of the HR departments are improve employee satisfaction to reduce resignations, reduce the cost of training and ramp up for the new employee, and also hire the better talent. To achieve these goals, we need to utilize Analytics Cloud to first identify which employees are at high risk of leaving the company. So objective here in this case from Smart Predict is understand the region of dissatisfaction, act on these reasons proactively to avoid losing employee, and identify which employee might be at potentially high risk of leaving the organization. So you can now see the data set. This is our data set. It's explained here in screenshot. This all data set as usual will be uploaded in our training material. Yeah, that's what we will be doing. So if you go back out there, I will show you the data set right over here. This is our data set. Remember, we are using the holdout technique where we will first train the model and then we will apply the model. So training and validation. So let's open the training data set. So you can see we have age, band, critical job alert, risk of leaving, impact of loss, yes, job category, yes, employee status, ethnic base, gender, generation, job family, job function, location, managerial employee or not, yes, employee name, employee ID, yes, successor ready, and then we have this flight risk. So you can see flight grouping and you see this flight risk. You can clearly make out the output of this column, or this column is just 0 1, it's binominal. So this is the data which is where the outcome is known to us. If you remember the last episode, what we said in machine learning, what we do, we first pass this data where outcome is known to us. Yes. And what computer does, computer will prepare a model for us, right? So we first pass this data where outcome is known. So in this case, the outcome is known to me. Yes. And I will give it to machine and machine will give me a model. That is what is happening. So this is my input, this is my output. This data set is called training data set. So you can see our requirement is to identify whether employee will leave or not leave the company. That's flight risk, correct? And based on flight risk, we will say whether he will leave or not. Where in this case, this is the last year data which tells me these employees have left the company. Yes. So like last year marks. So we already know the outcome. So this is our training data set. You can see the title. It's a training data set. So using this training data set, I'm going to train our model, our analytics cloud predictive model. And then we will have finally the apply data set. Okay. So we will have finally this apply data set. In apply data set, we will be able to have this year records of employee, and we will actually determine whether employee will leave. So in this case, you see flight risk is empty. It's empty. There is nothing inside. So we need to detect now with machine learning in SSE which employee will leave the company. So this is something which is now not known. Yes. This is your apply data set. You see apply data set. So first we have training and validation process, and then we finally have apply data set. Now coming to very important thing, if you want to utilize analytics cloud for machine learning, you have to create data set. So this was also a question asked by Mr. Narayan in the past. What's the difference between data set and model? So today is the right time. Let me answer this question. So data sets are raw data. They are unprocessed data. They are used for SAC reusability. So you can create a data set and keep the raw data. And if a developer need the same data, if multiple developer need same data, they can fetch it from the data set. Yes, they all can fetch this data from the data set together. Yes, so data sets are the raw data and they are used for SSE reusability. Yes, so we can store the data inside data set and reuse it again and again to also build multiple models. So this way we will not contaminate our data set. So data set is a pure form of your raw data. You can reuse it to build several models. Now, machine learning scenarios will only accept data sets in analytics cloud. Will only and only accept data sets in analytics cloud. That's what machine learning scenarios would do. So let us go ahead and see this in action now. We are going to create a data set. So first of all, I'll switch over to my SSE system. Just give me 1 second. I pause my screen to log in. In the meanwhile, anyone have any question? Any question on our scenario? What is the difference between applied and validation? Very good question. Can anybody wants to answer that question? What is the difference between applied dataset and validation dataset? Anyone? Last class? Anyone wants to try? No negative marking here. What's the difference between validation and applied dataset? No one remember last class? Anyone in the room who would like to just give it a try? Just have little confidence to give it a try based on last class. No one? No one wants to try? Difference between validation and applied data set?
Applied data set is training data, and validation data is the expected result.
Okay, very good. So applied data set is basically the data where outcome is not known at all. Is the data which we will use to to basically predict the output, our final output. But the validation data is used to use for the purpose of determining the accuracy. So you can see in the last session we use validation data. Validation data is a subset of your training data. You see, this data is a subset of your training data. So let me also type this question in the chat. It's a good question. Difference between training data and validation data set and apply data set. So training data set, as the name suggests, is to train our model. Okay, our predictive model is to train our predictive model. Then we have the validation data set, which is a subset of training data set to determine accuracy. And if you happy, the model is the training data model, the predictive model is ready to use. Yes, if you're happy with the accuracy, it's ready to use. And then finally we have the training, validation, and we have applied data set. Applied data set is a data set which we finally use we will finally use this applied data set to apply on our predictive model to get outcome. Yes. In this case, the outcome is not known at all. Now, if you look at the example, this entire data set, what you see here, is basically our sheet. If you see our sheet, we have two sheets today in today's exercise. So this is your train data set, train HR data. Yes, that's your train HR data. And then this one, the other one is your apply HR data. Where if you see the train HR data, the outcome was known because outcome must be known to also determine accuracy. So in the train data set, the flight risk is iteration, whether this employee will leave or not. One means employee will leave the company, zero means employee will not leave the company. Yes. So the outcome is known. So out of this data set, only some data set will be used as a validation data set. We cannot determine that. That is something which will be automatically determined by analytics cloud. Yes, automatically determined by the SAC. Then we have this apply data set where the outcome is not known. So in this case, the flight risk is empty. This column is empty, you see, it's empty. So this is the data finally we will use to help HR department. This is current year data. Imagine this is current year data. And the training data set is the last year data where we had last year data with which employee left or not left. Based on that, we will train our machine learning model. And apply data set is a data set where we now use the data set to determine the accuracy, determine the actual results. So using train data set, we will build the model. And that's what exactly I taught you in last class. We first have the data set where the outcome is known. We will give it to computer give us a model. Out of the same data, computer will also take a subset and do the check, get a predicted output, check the accuracy and tell us the accuracy. And once we have the model accuracy achieved, we have this model as final model, and on this model now we will use for further prediction using machine learning. That's the entire process. Yeah, I hope it's clear now. So let's go and use SSE. So I'm going to create data set. So I go to data sets here, this one. It's a raw data for reusability purpose. And we are just going to take this address and I'm going to upload. Remember, in the trial account, you can upload only 200 megabytes of data. So if we have problems in the future, then we will have to clean up some old models which we created in the past. So I just import now. So let me import. I'll go to my SSE training, and now I just go inside the just create a new folder. Just create a new folder, datasets, and we can just go inside dataset folder. And over here, we are just going to put our train dataset. So we are uploading our train dataset, and right after that, we will also upload right away the apply dataset as well. So you can see it's uploading. So now with the practical scenario, you will understand machine learning better. Last class more of a theoretical class, but I'm sure some of you have already gone through the video of last class again to understand today's session better. So now if I just go back, just save this data set. I don't touch anything at the moment on our data set. It's just a raw data. And next I will upload our apply data set also. I double click, import. So we switch over back to the spec. So this was our data set we've uploaded. So now you see on HR dashboard, you can keep KPI that your organization regularly track, including total number of employee, total number of early talents, as well as average tenure of each employee. Diversity represent a good balance between males and females in the organization, and the heat map shows the information about the high potential employees. Interesting information is about that high potential employees on the dashboard. It appears that 184 high potential employees are between 25 to 29 years of age, which means this age group of people are highest potential in a company. In addition to this, many high potential are account manager sales role. And as a business analyst, you generally interested to know how can you help HR to improve policies. You can understand the goals of HR department and reduce the cost to hire the better talent. So this is the existing dashboard which our company have. You can see where we have employee count, high potential employee count, average tenure each employee worked, yes, male female diversity ratio. Then we have a stack chart which shows high performance employee with different age group, and also the salaries across different departments and different regions in a heat map chart. So this dashboard is already there, built using BI. You can build this dashboard. I just gave an example. It's a simple BI dashboard based on what learnings we had in the past. Nothing new. But if you want me to show you building this dashboard, you can see it's covered in the premium POC course. So I already announced premium POC course for all of you in the past. So you guys can go and buy the premium POC course where I showed building this dashboard. It has nothing to do with machine learning. It's simple BI dashboard, which our HR already have. Yeah. So now upon importing this HR data, Tony is supposed to create training data set and prepare the data set to train the model. Since the outcome is binomial, anybody, when with the outcome is binomial, 0 or 1, which machine learning scenario will you use? It's corona patient or not patient? It's a heart patient or not patient? Yes, classification, correct answer. So since the result is binomial, 0 or 1, we'll use classification, and classification would be the right choice of scenario for analytics cloud. So our step number 1 was to create training data set. We did that. Yes, we uploaded the training and validation data set. Now you can see here we did that. And now what I'll do is I'll just go ahead and create a machine learning scenario on top of our data set. Let's go ahead and do that. So we can just go here more, and we choose predictive scenario, and we will choose here the classification. So we have three of them. I'll teach other ones later, but first we'll start classification. You see 0 or 1 classifying into. So you can hover the mouse and you see it also tells you something about this scenario. You want to predict membership of categories such as yes, no on a population rank from the most probable case to the least probable case. Example is to predict if the customer is likely to churn or not, or a manufacturing process component will require replacing within a short or a longer interval. These are the examples of classifications, 0 or 1. So it's a perfect example today that we are going to use our HR data set to predict if an employee is expected to leave the company or not. Make sense? So let's go ahead and use the classification scenario now. I click on that and we will just go ahead to this folder, and we're just going to create a new folder called machine learning scenarios, predictive scenarios. Click OK, and we just go inside predictive scenarios, and here we will put another folder called classification. Click OK, and now we are going to go inside, and now we're going to give our scenario like HR prediction for flight. So flight doesn't mean, guys, the flight, actual fly or aeroplane. It is all about, way to say employee will leave or not leave. Yes. So flight means whether employee will leave the company or not. It's like key. It's like a secret code word to detect if employee will leave the company or not. Yeah. HR prediction for flight. Click OK. Now you can see we have got here the description. So HR flight data risk flight predictives. And now we will choose our data set. So one question to all of you, let me see if you are paying attention, if you understood the scenario. Tell me, which data set will you use? Come on. Which data set will you use? Apply data set or train data set? Which data set will you guys use? Anybody? Anyone? Which data set will you be using at this moment? What do you think? Apply or train? Nachango
It's a
says
it's a trained data set.
train data set. Why? Because we don't have the predictive model right now. We want to have a
Right.
predictive model. And to build a predictive model, you need to train your analytics cloud, correct? So you should be using train dataset. Yes. So let me pick train dataset. And now over here, you can see some parameters to choose. So what's my target? Who will tell me what's my target in our data? Kaun batayega? Who will tell me what's my target? Let me open the dataset again for you. What's my target? All of this is the data. What's my target? Can anyone tell me what is my target?
Target,
The
it's like
last column.
what is last, right?
This is the flight risk. This is your
Huh.
variable.
Who leaving the company or
Yes, who will
not?
leave or not leave the company. That's your target. Very good answer. Yes. So in this case, it's already there. It's 1 0 is already detected. How can it be target if it is already detected? We already know who left and who not left. How come it is the target? How come? How come it is the target?
It's trained data.
Yes, very good answer. It's a training data set. Since it's a training data set, outcome is already known to us. Remember the marks example in the last class? Do you guys remember or not? To train a model, my friends, we need a data set where the outcome is already known. Yes, my output is already known. What we give to computer in machine learning, data and input in the past. With machine learning, we give input and expected output. So machine learning will build a model. So now we are already giving machine the expected output for each record, and machine will use these parameters to determine which employees will leave. Yes. So let me choose here target, come down to the flight risk, or just search flight risk. Yes, this is the one. Now, what are the influencers? कौन बताएगा? What do you think? What can cause an influence to leave a company? Think practically. What can cause an employee to leave company today? What do you think practically? Anyone?
And
What do you think?
Salary.
Salary. Very good. Very good. Salary will decide whether an employee will leave the company or not. Exactly. What else? Can age be a factor? मैं बूढ़ा हो रहा हूँ. I want to quit the job. I am getting older. Yes, can be. Organization tenure month? Probably not. Age? Maybe. Band? Which band are you working? I'm not happy with my band. I am not progressing
Right.
in this company. Yeah, I'm not happy. So band could be another thing. Am I feeling risky? Am I insecure of losing my job? Yes, before they will throw me out, I will leave them. Yeah, risk of loss, impact of loss. Yes, future lender, future leader. I consider myself as a leader, but our company is not giving me leadership position. That could be another factor. Yes, that could be another factor. Critical job role could be another factor. Job category. I don't like my job. They put me on the testing, but I like development. Yes. Employee status. Ethnic background, can that be a factor? Perhaps not. Yes. Gender can be a factor. Yes. I am a single mother. Yes. And I have to take care of kids, and I have to also take care of office. But sometime, yes, it's not manageable. So gender could be also a factor. Situation is not same for all the genders, right? Ladies have to do also homework. Yes, householding as well they will do. So gender could be a factor. Generation, yes, new generation these days, these people join the company just a 2 month experience. They join the company, they want to start up, they want to have their own company. Yes, could be a factor. Yes, could be. Job family, job function, location. Yes, I want to go to America. Most of the people want to work America. Yes, so location could be another factor. Managerial, minority cannot be. How many years I worked by far? Can employee name be a factor for leaving the company? If your name is Ram Shyam, yes, if your name is Michael, if your name is if your name is Jack, can that be a factor you leave the company? Can that be a factor? Have you ever seen an employee leaving the company because of his name? Anyone? What do you think? What do you think? No, certainly not. Employee ID and name is not a factor. Yes. Then we have salary range, employment type, am I permanent employee or contractor, high potential or not? Yes. Previous performance rating. What was the rating given by my manager last time? Yes. These are all the these are all the factors which will affect being an employee leaving the company. But now, if you look at, these are exclude as influencers. So we did opposite. We selected the ones which impact. We did not. We should select the one which should be excluded. Do you guys getting it? So we did opposite. We should exclude as influencer. We should exclude the ones which are not important. So what is not important? Let me put. Uh, so of course you have to select flight risk because that is already your target. Then what not impact? What not impact? Minority may not impact. Yes. Previous successor was not impact. Duration not impact. Readiness not impact. Maybe impact. Readiness might impact. Then we have current rating may impact. Maybe I uncheck these two. Grouping may not impact. These things I will select all of them as exclude. I don't want to include them. Then employee ID may not impact. Employee name may not impact. Yes, generation have impact. Ethnic background may not impact. So some of the properties I've selected as exclude. Exclude means do not consider these parameters to determine whether these employees will leave the company or not. Yes, exclude. And I say select. You see, variable as already defined as predictive goal can't be excluded. Okay, I think we should uncheck flight risk. Yeah. You see, now it's okay. So select flight risks, select the ones according to what you feel, guys. It's not like what I'm showing you. You choose exactly same. No need to be doing that. Yeah, no need to be doing that. Now you can also limit the influencers that it should use 10, 20, first 10, first 20. We can just right now say switch off and click train. So what it is doing, can anyone tell me? When I click on train button, what do you think it is doing? What computer is doing? What computer is doing behind the scenes? What do you think? What do you think? Faster, guys, faster. We don't have time. It's basically applying mathematical algorithm. It's basically applying mathematical algorithms on our training data set, on our training data set, and it is preparing models. So many models it's preparing behind the scenes. And then it is comparing these models by comparing the, the confusion matrix. Yes, by comparing confusion matrix, it's determining these all these properties: precision, fallout, sensitivity, specificity, accuracy, and then it is also determining the AUC and ROC curve. Yes, are you clear? Hello, what that train button does behind the scene? If you not understood last class, it's okay, but just understand what it is doing. It's just calculating confusion matrix, AUC and ROC curve behind the scenes. Is that making sense? Yes or no? It's determining TPR, FPR, all the formulas which I taught you is what it is determining. Yes, that's what the system is doing. Okay, perfect. So let's go and see what output we got now. And all of this is done by computer. You don't have to do it. That's why we use machine learning. That's why we use computer, because computer will do this for us. So now I go back to the output and voila, you see predictive power. Predictive power is basically how confident our scenario is to reproduce the same result next time. So if I give some data to this similar data set to this machine learning model, how accurate it will be able to produce the same result. Yes. Then comes prediction confidence. How confident machine learning algorithm is to produce and classify 0 and 1 correctly based on the validation. Then we have target statistics. So you see during training it has found 11.47% will leave the company and 88.53% population will not leave the company. Remember, it's all about classifying population to 0 or 1. During validation, it found 12.40% will leave the company, 87% will not. Do you see a big difference between training and validation? Do you see a big difference between training and validation of your classification? Not a big difference, which means this model can be trusted. Why? Because during training and during validation, the model is consistent. It is behaving consistently. Yes, which means this model can be trustworthy. And that's what prediction power says, 79%. It is 79% accurately determine, yeah, that the employees will leave or not, which employees will leave or not. Then influencer contribution. Which factor? Look at that. Age is the biggest factor today in our data set, which will deciding whether employee will leave or not leave the company. Look at this age. Then second is org unit. Third is tenure. Current. You see, surprisingly, salary is not a factor. Wow. In general consensus, we think salary is a factor, but it's maybe not. You see here, maybe not. Yes. So right now it's showing top five. You can increase here to see more influencers. Yes, you can sort them as well based on their contribution. This is all what we can do. Yes. And can anyone tell me What is this guy? Anybody, come on. What is this guy? Do you remember this? किधर तो देखा इसको? Where have you seen this? Yes, your AUC and ROC curve, my friends. That's why I taught you what I taught you yesterday. Today you are able to connect these pieces together. Yes. So you see what is green line? Can anyone tell me what is green line? Last class, come on. What is the green line? Perfect model. Yes, remember this one? This one? Exact same we got, guys. Exact same. You see? It's a curve between the TPR and FPR, and then you see this is your predictive model. If you wouldn't have done machine learning, this would be the line. Red line is the random. If you wouldn't have done machine learning, if you randomly pick, will leave the company, not leave the company, will leave the company, not leave the company, then this would have been the accuracy. But look at the machine learning is got you this. I will also go back and show during training how it is behaving. So I will just also add training. So you can see during training, this was the accuracy. So tell me guys, is yellow is better or blue is better? Yellow is better or blue is better? What is better? Yellow or blue? What is better? Yellow. Why? Sorry, orange. It's orange, not yellow. So orange is better. Why? It's close to the perfect model. So during training, our model behave like this. And during validation, our model behave like this. Yes. It's near perfect. Nothing can be 100% perfect. Remember, it's probability. Machine learning is a probability. Yes. So for orange one, AUC is bigger. It's better. So it's still at least you see this gapping between the orange and blue is very less, which means this model can be trusted because it's behaving similar during training and validation. Then we have influencer contributions. You can see age, yes, org unit, different things you can see over here. Yes, these are the different things you can see here. Org unit level, tenure month, age, employee status, gender, performance rating, job function, yeah, everything. We can see different parameters. You can see salary is somewhere down, guys. Maybe this company is giving good salary. Salary wise, people not have a big problem, you see. But age wise, there are people who are creating problem to leave the company. And org unit is the second biggest factor. Yes. So that's surprising data which we cannot anticipate. Human, as a human, we think salary is the only factor, guys. Salary is today, salary is not the only factor, it's not in reality. What, as a manager, what I see these days, people are ready to work less or equal salary than the counterpart offers, but they want respect at work. Yes. And they do want to do want to see their work is recognized, and everybody wants to have a good work life balance. So if you're working in an organization unit where the work life balance is very bad, employee will suffer leaving the company. Yes. Yes. So that's a reality today. So good, we got some data. And then you see between grouped category. So if you see, age is the biggest factor. So within this age, which age group is expected to live more? So see, people between 21 to 48 year, yeah, they are expected to live more. Yes. Between 53 to 70, again the second one. Between 48 to 53, 19 to 21, they are leaving. There's a chance that they will not leave the company. So contribution of the group category you can change also. I want to see which salary range is expected to leave more faster. So see, employee which has significantly exceeds expectation are also leaving the company, and the ones which are meeting and fail to meet expectation are not leaving. Means this is the rating, basically previous performance rating. So people who have high rating, which means they have high potential, they will expected to leave the company faster. Yeah. So you can see here different factors. You see, females are expected to leave faster than males. Yes, that's another factor. So this is our data set. You can analyze each of the factor accordingly. What range of salary people leave faster? You see, in the lowest range of salary people or mid range of salary people are leaving faster. So these are the different data sets. Then you see grouped category statistics. In this you see age. So this is basically how frequently the event is occurring. So people between the age of 10 to 19, it is very high frequently, means this age group of people are leaving very frequently, yes, as compared to the other age group in terms of population. So you see on the x-axis we have frequency of positive target. So how often the one is occurring, 1110, it's just about 10, how often the one is occurring. So over 21% of the people, yes, over 21% of the people between the age group of 53 to 70, the occurrence is 13%. So frequency is 13%. 13% of the people in this group of people, 53 to 70 age group, 13.2% people are identified to be living. 21.03 uh, of them will leave the company, and this is the frequency of occurrence. So these are the parameters, and now you see confusion matrix. Remember last class, confusion matrix: predicted, predicted 0, actual, actual 0. So can anyone tell me what is this first quadrant called? Anybody? What is the first quadrant called? What is the first quadrant called? I need to unshare and share my screen again because my pen is not working. I need to share again because my pen was not working. What is the first quadrant called? If you would have gone through the last class properly, what is this first quadrant called? True positive. Very good answer. TP. Very good answer, Rahul. TP. But Rahul, I would say please not answer privately, answer publicly so everyone can see your answers. True positive. Yes. Actual predicted. Machine is saying they will leave the company, and yeah, they actually left the company. Yeah. True positive. Machine is saying machine is actually they left the company. Actually they are heart patient, but machine is saying they are not. This is false positive. Then this is true negative. Machine is saying they will not leave, and they actually not left the company. True negative, and this is false negative. Are you guys clear? Confusion matrix last class. If you forgotten last class, please go back and check the video of the last class. Yes, this is what exactly we learned in the last class. Which quadrant you want to improve? If your model has a better accuracy, which quadrants? Quadrant number 1 and quadrant number 4 we want to increase. More these quadrants, better the accuracy of the model. Yes, better the accuracy of the model. Very good, guys. Very good. I'll come to this contacted population and detected target in few minutes. Give me 1 minute. Now coming down, you see classification rate, sensitivity. Remember what is sensitivity? TPR, 62%. Specificity, precision, fallout. Yes, all these parameters were calculated based on the confusion matrix automatically by computer. Automatically by computer. This is the beauty, guys. This is the beauty. This is how SAP Analytics Cloud is actually predicting. It's actually predicting our outcome. Wow, guys. That's truly amazing. Yes. So I hope you are able to digest today what we learned in last class theoretically is what is practically happening today at front of us. Yes. This is what is practically happening today at front of us. Yes. So this way Analytics Cloud help you to determine the accuracy of our model. Yes. Accuracy of our model. These are some of the formulas which we also saw in the last class, and we are able to now see these formulas in action over here. Yes, this is the beauty of Analytics Cloud predictive model. Everything is done automatically. We don't have to do it. Things are done automatically by the system. Yes. So now the next thing which we will see over here is very interesting thing which I like so much. How do you prove the management that Analytics Cloud is worth enough? Yes, the real power which comes, how much cost saving you are doing in your company, and this is called profit simulation. Yes, a profit simulation, you see it's the same thing. These sliders you see they are also here. So profit simulation will tell you what if you wouldn't have used Analytics Cloud machine learning scenario. Yes, what if you wouldn't have used this, what would be the the accuracy, It would be random. Yes. And with machine learning scenario, how much is the accuracy and how much cost saving you are able to do. Yeah. So now let me just put here, let's say cost to contact each employee is $1. So what is the cost for predicting a positive target? $1. And what is the profit for actual positive target is $10. What does it mean in our scenario? It means if I contact each employee today, assuming that each one of them will leave, the cost for me is $1 to contact that person, call that person, give him some benefits, give him some vouchers, give him some benefits, some health benefits, some travel benefits. Yes, to the make employee happy. The cost is $1 for making each employee happy. Yes, and the if that employee because I spend that cost, if that employee is happy, then eventually he will retain, she will retain, and the saving will be $10. That will be the profit for actual positive. Saving will be $10 eventually. Yes, that is what will happen. So by considering the unit cost versus the profit, we will now determine the profit, how much profit we are saving. So let me explain this calculation in detail. I will go back and I will put here the profit simulation. So watch out this carefully. This is again some mathematical calculation. So total number of employees. How many total employees are there? So if you go back to the slide, you see the total number of employees are 8,000. Yeah. You can also count our records in Excel sheet. You will find their total number of employees. So then comes is what is the cost to contact each employee and make them stay in our company. It's $1. Just now we put that cost. What is the if the employee stays with us? What is the profit he or she brings to company? $10. Yes, $10 is the profit. Now, with machine learning in Analytics Cloud, we have found out that out of out of how many employee machine learning is looked at, it looked at 12.4% employees. You see, percentage. It has looked at 12.4% of population. And in this population, it has found out 62.1% positive targets. Yes. So out of 12.4% employees, SAC has shortlisted to number of detects is 160. Yes. SAC has shortlisted. You can increase this also. You can see, you can increase. You see, I'm increasing and decreasing. So I can increase and decrease. So I can say maximize profit. Yes. So out of 31% employees, it has found out 218 employees were detected, which are expected to leave the company. So let me put this 31.7 only, or let me go back to 12.4 initial number, or let me just use 31.7 only. So out of 31.7% employees, it has contacted 31.7. It has contacted, it has shortlisted how many employees? 218 employees in total. It has uniquely identified 218 unique employees, which SAC thinks will certainly leave. It has detected them, yes, with machine learning. Now let's put this in calculation and identify what is the cost to contact each employee. So total 218 employee, it is found out. You see 218 number of detects multiplied by $1. So total cost I spent is 218 USD is my cost. Okay, this is my cost. So this is the cost I am spending when it comes to SAC. Okay, so this is the cost I spent. And now what is happening is we are going to determine, one second, I need to charge my laptop. So this is the cost to determine each employee, how much is the cost to make that person retain. But if that person retain, what is the savings? Yes. What is the savings? Yeah. So this way we will calculate also the saving now. So how much is the saving? So if these 271 or these 218 employees will retain back, yes, it seems that 81% will, how much percentage will certainly leave? So 660 employee it has found actually. I'm so sorry guys. 660 employees it has found. It is out of 31.7%, 660 employees it has found. 660 employees. The cost will be $660 to contact them. So you see, these many percentage, these many employees. So 60 people I will contact. Out of this contact, it has found out 218 will leave. So now what is the saving? If these 218 will not leave, so 218 multiplied by $10. So 2180 USD saving you will have in the company. Okay. So first and foremost thing, we looked at the number. We found out that out of these many employee, if you contact, machine is telling you contact these 660 people. I'm telling you contact these 660. To contact these 660, the cost is $1 per employee. So $660 is the cost. Out of this, it has found out 218 people is expected to leave. Out of the 660 you contact, 218 will leave. But now they will not leave because you contacted them. So the saving will be 218 into $10. This is $2180 is the saving for you. Yes, this is your saving by contacting people with machine learning. Yes. So what is your net saving? Net saving is total saving 2108 minus the cost 660. Your net saving is how much? 2180 minus 660. You are saving 1520 US dollar. This is your net saving with the help of machine learning. Now I will go back. Now I will go back and show you what will be the saving in case, or what will be the case if you do not go with machine learning. If you do not go with machine learning, what would be the case? Yes. So imagine if we wouldn't have machine learning, we need to contact same percentage people, assuming, because if you want to compare, you need to also consider the same percentage of people. So same percentage of people you will contact now, which is 31.7%. So what is the number of contacts you need to do? The number of contacts which you need to do now is number of employees 8,000 into 31.7% people if you're contacting. Yes. So what is the 31.7%? 8,000 into 31.7%. 951 people you need to contact. So the cost to contact is $1 per employee. So it is $951. So you spend $951 eventually to contact these employees. Make sense? That is what you will spend. So this is the cost, 8,000 into 31 point. Okay, guys, I'm so sorry. 8,000 into 31.7%. It is 2536. I'm so sorry. 2536. This is the cost, guys, if you go randomly, if you need to contact exact same population, 31.7%, but to compare it with machine learning, yes, this is your cost without machine learning. Without machine learning. In case of machine learning, it gave you exact 660 people by analyzing 31% population. But here, you just go randomly. You don't have any number of people which is detected. You just go random, and the same percentage. So this is the cost which you have. Yes. Now, out of this, what was the last year iteration rate? What was the last year iteration rate? Last year iteration rate was, it's given in the number, 10.625%. This was the last year iteration rate of people leaving the company. So now if you contact these many people and you found out, yeah, out of this, assuming the last year iteration rate, 10.625%. Out of these people you contacted, let's assume you saved. So what is your saving without machine learning? So out of 2536, you now saved 10.625%. People will not leave because you contacted them. So is out of these many people you contact, iteration rate was this. How many people will now not leave company into 10.625 divided by 100? Around 269 people will now not leave the company. $10 is the saving per person. So 2690 is the saving. What is your net saving? 2690 minus 2536. So 2690 minus 2536. $154. Do you see the difference? Without machine learning, you just have $150 saving. But with machine learning, you have 1520 US dollar saving, guys. Do you see the huge difference between the savings? So if you compare ML versus non-ML, yes, 1520 minus 150. You are saving extra 1370 USD extra you are saving. And how much is this percentage? How much is this percentage for 150? Yes, 150. So 150 divided by 1370. No. So it is 137000 divided by 150. 913% extra saving you're doing. Yes. This much is the extra you are saving with machine learning. If machine learning wouldn't have been there, you wouldn't have this saving. Wow. If you go back, it's doing exactly same. You see, 1520 using predicted target. With random, it is 160. So you see, our saving was $1520. You see, this is our saving with machine learning. You see, 1520. You can see exact matching, 1520. Yeah. And you see, $160 is with the random contact. You see, almost matching. 150, 160, almost matching, guys. Extra saving 1360. You see, 1370 extra saving. Yes. And percentage wise, 913%. You see, 850% saving. Extra saving you have. Are you guys clear how we calculate profits? How does Analytics Cloud is saving you more as compared to if you wouldn't have gone random? If you wouldn't have used Analytics Cloud, how much extra saving you have? Are these mathematic calculations clear to everybody? Yes or no? Okay. Yes, fair enough. You need to practice. Fair enough. You can practice. You can watch this video again and practice. Put down these numbers on the paper. Try to change, try to change this slider and then calculate yourself the way I calculated. Simple maths on the paper. You will find the numbers correctly. That is how you can explain it to the business also. Why I'm teaching you this calculation so you can explain to the business. Yes. These are all calculated behind the scenes. Okay, any questions? Any questions now before we move ahead? Any questions? No? Okay. So our model is ready. You see, predictive model is ready with 79 and 85%. If I'm not happy with accuracy, what can I do? What can I do if I'm not happy with accuracy? Remember supervised learning. What do we do if we are not happy? कौन बताएगा anyone? Last class. Supervised machine learning.
AUC, reduce AUC.
No, 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 no. If you're not happy with accuracy of your machine learning model, what do you do? What do you do? Come on, guys. If you are not happy, supervised machine learning, if you're not happy, what do you do with accuracy if you're not happy? No, 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 no. What do you think? It's there. The answer is right over there on your screens. You just have to read it out. It cannot be as simple as that, guys. If you are not happy with the accuracy determined by Analytics Cloud, what do you guys do? If you're not happy, answer is right at front of it. It's right out there on your screen. You are not able to read. Think about it, guys. Think about it. Yes. Very good, Mahesh. It's a retrain. You need to retrain your model. How? Come back, copy this model, duplicate. So make a copy of the model. You see, I click and now I change my factors. So maybe I limit my exclude factors by, let's say, only 8 factors. Maybe. Yes. And I will exclude some more factors from this list of factors. I'll exclude some more factors. Yes. So let's say this, yeah, this. Exclude some more factors. This, yes. Exclude some more and train. So it's training again. And now you see it's training. And now we'll see if I exclude some more factors or if I include some more factors, how is the impact? So this way you can include or exclude some factors and you see this time prediction confidence increased, but predictive power has reduced. So this way you have to retrain and check which is giving you better prediction power and prediction confidence. Is that clear, everybody? Supervised machine learning with Analytics Cloud. Retrain by changing your parameters and then see what gives you the best results. And that is the model you will go ahead and take it. Yes. Okay. What is the next step after the training is done? Let's say you found out this model is best. Model 1 is best. What is the next step? Who will tell me? What is the final and the next step? Anyone? Anyone? What is the next step and the final step? Yes. We now have a predictive model. Why we develop machine learning models? What was the purpose? To finally use it and predict and start predicting. So which data set will you use now to predict? Which data set will you now use to finally predict? Which data set? Apply data set, because apply data set, the outcome is not known. Yes, outcome is not known. If you remember this applied data set, the flight risk was empty. The flight risk was empty. You see, it was empty. We don't know. This is current year data by HR. HR wants to know early which employee are at high risk of leaving the company. This is what HR wants to know. Yes, we want probability. How many employees will leave? Yes, that's what we want. So now I go ahead. We have already uploaded this as a data set. So we go click this factory icon. We choose our data set as apply data set. Why it's not showing here? Something is wrong. Maybe I just have to go to quick refresh. Yes, I click. Oh, I'm so sorry. I by mistake saved it here, guys, outside. I'm so sorry. Yeah, this is our applied data set. I'm so sorry. So I click, select that. I say replicate. I want to replicate everything, almost all the columns. Yes, maybe. And of course, flight risk is mandatory. So we just replicate these many columns in the output, click select, and then we say what I want to export. I want to export the prediction probability, prediction category, and I want to export assigned bin and prediction explanation also. These many things I want. And this will create now a new data set. It will not contaminate your existing data set. So we go back to the scenarios, machine learning scenarios, classification, and now we will say output, HR flight risk. This is my output data set, which will tell me which employees are expected to leave the company. You can see it is applying now. You see it's applying. You see it's applying here. And in few seconds, you will see it's done, which means a new data set you see applied. A new data set would have got created. If I go to our folders, SSE training, predictive scenarios, classification, the output data set is created. Wow. If I click this data set and open, you will see system would have calculated for me the probability of which employee will leave or not leave company. You come here, you see you have got prediction probability. There is 52% chance this employee will leave the company. 13% chance this employee will leave the company. Yes. And you see explanation also. And you see here explanation. What factor is affecting this employee to leave the company. Yes. And then you see predicted category. You see 0 1 0 1 0 1 0 1 here. You see one. This one means this employee will leave the company. Yes. What is assigned bin? What is assigned bin, guys? If you remember the last class, if you remember the last class, we have this we have this this chart. Yes. And if you see, we had different threshold values. Yes. So these values are, some values are close to 1, some values are close to 0. So if you divide the entire chart into 10 equal parts, you see these lines, 10 equal parts, then you see some data points will lie, some data points will lie in different levels. Some employees will lie here, some 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 employees will lie here, some here, some here, some here, some here. So you can see this employee is, let's say, Alex, and this employee is, let's say, Divina. If I have to choose between Alex and Divina, which employee I should go and meet immediately? Yes, if I have to choose between these two, which employee I should go and plan my meeting first? First, I should plan my meeting with who? Divina or Alex? Which has high chances of leaving company? Why Divina, Nachango? Why? No. Which is close to 1? Which is close to 1? Divina or Alex? Which is close to 1? It is close. Alex is close to 1, right? So if I have to plan a meeting, I will plan with Alex first as compared to Divina. Yes. If tomorrow my manager asks between Alex and Ravi, which employee have higher probability to leave? Between Alex and Ravi, which employee do you think have higher probability to leave the company? Have higher probability to leave? Of course, Alex, because it's close to 1, predicted as 1. Yes. So this is how you see these data points are put in different zones. This is one zone, this is another zone, this is another zone. Yeah, you divide your chart into 10 equal parts, and these are different zones. These zones are known as assigned bin. So this assigned bin will also help you to identify out of all the targets which targets are more close to one. Yes, that is what it does. Yeah, that is what assigned bin identifies. Okay, so yes, now we have got the data, and all the nulls we will mark it as 0 only. We'll assume they will not leave the company, so I will replace all the null values with 0 only. And now we will build a dashboard. Yes, so we have kept it 0, all the ones which are null. Yes, we have some 1, some 0, and now here also I will mark it as null. Replace all the values of null with 0. Yes, perfect. And now what we will do next step, guys, we will go ahead and create a model out of this data set so we can build our story. So let's save this data set, and we will build a model to put all these predictions out there on the screen for HR to analyze. So I'm just going to go back, create a new model. You can create a story on top of the data set directly, but it is a good practice to always create a model. So let me build this dashboard and then we can break. So I click on new model from data source, and I come down to data set, and I will say SSE training, predictive scenario, classification, and my output data set I will choose. So it will fetch all the data. It will copy back this data to the model. So I've got the data, and I can click on create my model. And before that, I will also just check this assigned bin. I will mark it as a dimension only, generic. So we can further categorize. Okay, all looks good. Let's create model. Create. I go to SSE training, predictive scenarios, classification, and I say model, output HR data risk. It's done. And let's create a story. Go to canvas page. I go with classic design, and I will first create a donut chart, and I will choose the model which we just prepared out of our predictive result. And my first chart is going to be a donut, which will show employee count. So I'll create a new calculation with the aggregation to count number of employee IDs. So I'll put all the count, and I want to know based on predicted category how many employees are expected to leave. You see, 10.7% employee will leave the company, 89% will not leave the company. That's a predicted result by machine. Machine is saying 10.79% will leave your company. Yes, good. Let me put the next chart. You see, all of this is given in spec. If you come down to the spec, you see everything is explained here in the spec. Yes, and this is our data. So again, employee count per assigned bin and predicted category. So we come back, employee count per assigned bin and predicted category. So as I told you that the ones which are going to leave, within that also we have further priority. Yeah, the quadrant which is coming close to 1 and 2. Yes. So the one which are going to leave are also like this. I can also sort and rank my data. So sort based on predicted category in descending order. So you see these are the employees which are expected to leave. So the ones which are expected to leave, within that also you have priority 1 and 2. Yes, which are more close to that. So I'll put it here. Yes. Let's go ahead next. We put a table now for all the employees. We will go ahead and add rows as employee ID, employee name, employee flight risk, sorry, uh, the prediction category and org unit and salary. So salary, predicted category, and also probability, high probability which employee will leave. So probability will come inside this account dimension. So you see prediction probability. So this is our output. I'll just keep probability over there. So you can see for these employees, how much is the probability. System is also telling that for leaving the company. We can sort them in descending order, highest to lowest probability. Yes, that's what we can do for these employees. Okay, so now this is our data for the table. Finally, we will add a filter and we will add it on job category. So we can also filter based on different job categories, these employees in the data. Let's also add a background. So this background image is given to every one of you. So we will just go back to add image control. I go to our SSC material. Yesterday I've uploaded the images in our training material. Nochango, you asked me for that same. I've did that. I'll pick up this image. I now go zoom out level and increase the zoom size of this image to cover the entire page. Then we will send this image to the background. So we go back to the styling panel and send this image in the background. And now we go to the preference. Because it's a dark background, it is recommended to have a light color. So we will put for everything light color. White is good always. Yes, makes sense. Apply everywhere. So we should see a better look and feel of our dashboard. Beautiful. So you can see here, now we can also add a linked analysis finally to my table control. And we can view the dashboard. So that's your dashboard. And you see if I just click these 203 employees, which are expected to leave with high probability, it will filter my table and will find out which are those 203 employees. Click. It filter the table. You see this person has 97 probability to leave the company. Susane, yes, Gerald, these are the people having high probability. If I go back and just choose the least probability, my table will get filtered. Okay, it's not filtering, something is wrong because we have not checked the checkbox. Filter on data point selection was not checked. Now give a try. Yes, you see table is filtering now. So you are getting probability and also the chances of that employee flying away from your company. Yes, you can just drill down and help HR to find out this list of employees. Superb. So that is about our classification scenario where we are able to now predict which employee have a higher risk of leaving our company this year or not. This is called classification scenario, and we did that with the help of machine learning. So let's first take up your questions. Any questions on this entire process by far? Training, retraining, applying, creating model out of dataset, then creating a dashboard for the HR with prediction, category prediction confidence and probability. And also profit simulation, AUC curve, ROC curve, confusion matrix. We did all of it step by step in our classes. Any question, anyone so far in our current class? Okay, yes, you need to practice everything. You will be able to get through it. Okay, let's take a break here and we will resume after a short break of 5 minutes. I'll start the timer and we'll be back after a short break. Okay, welcome back after the break. So before the break, we talked about our scenario for doing classification. Now, in our current scenario, what we are going to learn, what we are going to discuss is we are going to now talk about the concept of working with our next scenario, which is regression. Before we just switch to the regression scenario, let's try and understand what we will do now when it comes to working with regression scenario. Before that, we need to now just go ahead and talk about how to quickly understand this concept of dependent versus independent variable. Yes. What is dependent versus independent variable? Let's talk about that. So let me put a simple table over here to just explain you a bit. So I will just put here a simple table with a couple of examples. So now I'm just going to come here and let me put an example for a student. So let's say student name, student roll number, then we have the, let's say, hours of study, how much our students study, yes, how many books student refer, yes, and let's say also what is the timing at the time when students study, and then also we will put here marks, yes. So I will put the name as, let's say, Alex, and then I'll put John, then I'll put Vitalik, we put Rubina, and we put Sayed, and then we'll put roll number 1001, 1002, 1003, 1004, 1005, and so on. Let's say Alex study for about 6 hours a day, 5 hours, 6, 8, 3. Books, you refer one book typically, two book, one book, two book. And the timing is evening, study in the evening, study in the morning, early morning, afternoon, yes, evening and morning. And now let me put here simply the marks. So let's say he scored marks out of 100, let's say 90, 95, 80, 75, and 50. Yes. So you can see in this scenario, the output variable is of type a number. It's a numeric value. Okay. So whenever you have outcome is of type numeric value, we will use a regression scenario like price of a house. That's a regression scenario. Now in this table, if you see, can anyone tell me what are the factors the marks of a student depend on? In this table, what are the factors the marks of a student depend on? Anyone? marks of a student depend on what are all the factors? Anyone? Quickly. Hours of study, very good. Number of books you refer and when you study. Yes, sometimes some people like to study in morning because morning things will get remembered faster, right? So in this case, we want to predict marks of a student next time. Yes, that's the area of prediction. And the clearly you can see the number of marks which a student score depends on these three factors. Yes, and it does not depend on these two factors. Perhaps not. Yes, if you think logically. So the output which you see here, this is the marks. This is you called your output, yes, or your predicted result or your output. It's actually also known as dependent variable. Can anyone tell me why it is a dependent variable? Any reason? What do you think? Why it is called dependent variable? Yes, because how much marks you score depends on other values, right? Yes, marks which you score depends on other values, which are these three, correct? So that's why my output here is dependent variable. So whenever you do machine learning, a dependent variable is your outcome, your output. Yeah. So it depends on other variables, which are independent variables. Okay, independent variables. Independent variables. These are your input. And the ones which directly does not influence actually your output are called outliers. What are they called? They called outliers. They're called outliers. Yes, they're called outliers because they do not clearly influence your dependent variable. So we should avoid outliers, we should respect independent variable, and we should predict dependent variable. Is this concept clear to everybody? Is this concept clear to everyone? Yes or no? Yes. What is dependent variable? What is independent variable? Yes. Perfect. So now we want to go and talk about regression scenario in Analytics Cloud. So regression is a technique to identify. What is regression? Regression is a technique to identify a dependent variable of nature. If your dependent variable is of a nature of numeric or continuous nature, not binomial, but it is continuous nature. Remember the data types which I taught you earlier on machine learning. So if your dependent variable of nature continuous, then we use regression scenario. Remember this. When do you use classification scenario? When your dependent variable is of nature binomial, 0 or 1, then you use classification, the previous one. And this one is continuous nature because if your dependent variable is of nature continuous, you use regression scenario. Clear everyone? Classification versus regression. Yes, that's the difference between both of the scenario. Classification versus regression scenario. That's a difference. So let us go ahead and now see an example of how do Analytics Cloud use regression or determine the value of a dependent variable which is of continuous nature. Regression, and how regression typically works. Let's talk about that. So regression is a scenario, machine learning scenario in Analytics Cloud, where we want machine learning to predict our outcome or our target, you can call anything, or our dependent variable. Yes, our outcome or output, predict a value, predict a single value, which is your outcome, your target, or your dependent variable based on independent variable. The nature of output must be numeric, number, or continuous. Please check the slide where I explained the data types in machine learning. When your output is of nature continuous, it's a number. That's when we use regression concept. Okay. So now one another thing, if the if the dependent variable only depends on exactly one independent variable, only depends exactly one independent variable, then we use linear regression. Linear regression, which means you are exactly depending on only and only one independent variable. What is the example of this? Example of this could be that you have, let's say, um, what can we think of? What can we think of? What can we think of? Yes, I wanted to know the quality of a product, quality of a product, and the quality of a product based on only one factor, whether it passed the test or failed the test. Yeah, it failed the quality inspection or passed the quality inspection. So in that case, my dependent variable is the quality rating, which is a number. It depends on only whether it pass or fail the test. It's just one factor, one independent variable. Yeah. So if the dependent variable depends exactly one independent variable, then we use linear regression. But if the dependent variable depends on multiple factors, multiple independent variables, then we use multi-regression. Multi-regression. We use multi-regression. Now, regression is nothing but it is basically a simple algorithm which we learned in school days, y equal to c plus mx. If you remember, this is the algorithm which we use in the past. Y equal to c plus mx. C is the quotient, m is the m is basically the slope of the line, and x is your x-axis. Yes, so that is what regression concept is all about. So let's quickly discuss about single regression or linear regression and multi-regression. So in case of simple regression or linear regression, the equation is equals to y is your output variable, your dependent variable, equals to alpha 0 plus alpha 1 into x1. So here alpha 0 and alpha 1 are called coefficients. They are called coefficients. And x1 is your independent variable, which is the only variable influence your predicted output, and y1 is your dependent variable. If you use multi-regression, then we have y1 equals to alpha 0 plus alpha 1 into x1, alpha 2 into x2, alpha 3 into x3, alpha 4 into x4, and so on. And all these are coefficients again, and these are x1, x2, x3, x4. All these are your dependent variable. All these are your dependent variables. And y is your predicted output, which is your Sorry, these are your independent variable and this is your dependent variable. You see, y depends on x. So that's why it is dependent, and x are individual variables. This is why they are independent. Now let's take an example of price of a house. Yes, I take an example of a price of a house. I want to determine price of my house. So this is y. Now, what are all the factors price of my house depend on? Anyone? Price of my house depend on what? How much BHK the house is, correct? Yes. What is the location? Is it close to airport or station or public services? Yes. What is the size of the road? Yes. Then how many number of floors are there? Which floor the house is located? Then name of the house, Shanti Vilas, Shanti Kunj, Vasant Vihar. Yes. Name of the house, correct? Color of the house. Yes. What else? Whether house has water tank or not. Yes. Yes. What else? Name of the owner name of the house. Yes. Now, can anyone tell me out of these 8 factors which I put over here on the screen, which factor do you think is the most influencing factor to predict price of a house? Which is the most influencing factor to predict price of a house? Anyone? Yes. BHK. Location. Yes. Number of floors. So if you see, this is high weightage. This is high weightage. This is medium weightage. This is medium weightage. This is zero weightage. Name of the house could be anything. Shanti Kunj, Vasant Vihar, doesn't care, right? Doesn't care what name you keep. You can keep a small 1 BHK name as Ambani Villas, but that does that make Ambani Villas? Perhaps not. Yes. No. Color of the house may be very low weightage. Water tank on the house is not low weightage. Name of the owner zero weightage. So you can see this alpha is the factor coefficient which is basically telling you how much weightage each of the component is to predict the value of your independent variable. Are you guys clear? What is the value of alpha and what is the value of x1, x2, x3, x4? Is this clear, guys? Yes or no? Is this clear? Yes or no? Is this clear? Yes or no? Everyone? Yes. So x is your independent variable and alpha is your coefficient variance. They are the weightage. Yes. So to determine price of a house, we will see which one of them have high weightage, and accordingly we will use it. Clear? So this is the concept of multi-regression and single regression. So we will basically rely on these different weightages, or how much is each variable is depending on. So this is the concept called regression. In the next class, I am going to show you. So like we had rules to determine accuracy of our model, like confusion matrix, AUC, ROC curve. Similarly, for regression also we have some rules to determine the accuracy, and that is called residuals. And based on residuals, we have some formulas based on which we will determine accuracy of a regression model. In the next class, we will start with that, and we will build again a machine learning scenario with a practical example for regression in the next episode. This comes to the end of today's class. Any questions before we close? Any questions before we close? No? All right. So,
Hi, Anubhav.
hi.
I have a question. Yes,
Yes, please.
Anubhav, this like the data set which you create today. Yeah,
Mhm.
this can only be used in predictive scenarios.
No, the data sets. Okay, good question. Very good question. I want to answer it in the PPT so that you can remember as well. So remember one thing, for machine learning scenarios that I've already mentioned, machine learning scenario will only accept data sets, not model. But data sets can be used to create model as well as directly in stories. Yes, you can. You can. It's allowed. But recommended practice is to not contaminate data sets because they will be reused by multiple developers in future. So you don't want to contaminate your data set. So instead, create copy by creating model and apply transformation only on model, not on data set. Because if you apply transformations on data set, it will contaminate your data set. Yes, this is the main reason, guys. This is why we should avoid using data sets for stories. Does that answer your question?
Yeah. Thanks, Anubhav.
This is the best practice.
Anubhav, okay, Anubhav, I have another question. Like in the past, we have this sales data model, yes. And now I am thinking that maybe if I wanted to use the same sales data model to bring the predictive scenarios,
Mhm.
but
You need to
that
first
data
create
set,
data set using the Excel.
okay, okay,
Yes,
okay, okay.
yes.
Thanks, Anubhav. Clear, yeah.
Welcome, welcome. Okay, so thank you so much once again. I don't know, guys, how much you digest out of what we learned. It's okay if you could not understand, but if you understand the broad concept, it's more than enough for the class. Now the work is pending. You guys have to go throughout the next course of weekdays and just go through the classes, videos once again. Try to slow down the speed of my video and try to put your notes. That will help you a lot to understand these concepts better. Next week we just have one day class on number 27. On number 28 I am on holiday, so we just have one class next weekend, which is 27. Yeah. 28th, we will not have a class. So you guys can plan your Sundays accordingly. I'm informing you 1 week ahead of the session. So 27th, we will have class, but 28th, we will not have the class. Thank you so much once again. See you next week. Goodbye.